Greetings, everyone, and welcome to our second part of the webinar SmartNodes++. Sitting next to me today, Oliver, Head of Technology at CleverThis.
Hi.
My name is Robert, I'm CEO at CleverThis, and I will be today moderating the webinar. I'm taking all the questions and that you might want to send, any challenge that you might want Oliver to resolve online. Yes, let's start with the presentation. So again, this is the second part for our webinar that we started to introduce last week. I'm just going to give a quick intro, just recapping what we saw last week, really very quick, and then we will jump immediately into a live demo from Oliver. And as soon as you want, like last time, start throwing in the questions. There is a Q&A in the left side of your screen. You can start proposing any challenge for Oliver or sending me any question, and we'll do our best to answer online. Very quickly, like we said last week. So what is SmartNodes++ for? What does SmartNodes++ help you to do? As we said last week, you can design projects which includes auto-generating your data point structures and your code, multiplying your engineering productivity. So in practice, becoming highly competitive, whether you're a system integrator making projects for a customer or you are an end user of the application, you just become faster at bringing your systems into production, at bringing new features into life, and so on. And at the same time, you significantly reduce your maintenance and effort cost. That's very much probably on the OT side. If we get more into the IT developer side, SmartNodes++ helps to quickly develop high-impact operation management applications, which means that you can really develop your OT applications, you can connect to your hardware and so on, but you can also very quickly offer different features to your customers. So Oliver will be showing briefly today. So it's in fact bridging IT OT, the usual concept of how do we connect OT systems with IT, which in practice, when we say bridging OT IT, we mean how do we bridge to our enterprise systems, And finally, SmartNodes++ can help to encapsulate your knowledge and your software assets by creating portable applications, perhaps just to commercialize them, or perhaps just because you have many sites, or because you can capitalize the value by moving them from project to project. Let's just jump into the part one summary again very quickly, because the other day we discussed and we said there are two parts where SmartNodes++ can help, just because WinCCOA and its open architecture is a very powerful tool that can allow us just not only to connect to the hardware, but also its open architecture allows to model IT and enterprise systems as well and create business and control logic. SmartNodes++ helps to do this. Last week, Oliver modeled some conveyor line, some conveyors using a model that we call Quicker. Quicker allows to create model objects, object classes. You can model the attributes, you can model the methods. So in practice, SmartNodes++ is doing something for the developer, which is connecting the attributes of an object, so a conveyor, for example, also with the behavior of the conveyor of the object. So it is actually packaging to some extent these two, and it's taking care in the background of creating data point structures and so on. So Oliver did this last week with a conveyor, and he then used a module which is called Checker to actually test that this conveyor is working properly. So he used the module to create some unit tests and check some functions. Checker can also be used to do functional tests, which is beyond just checking if a specific method of an object type is working, but also checking at a more higher level if I send a command to an enterprise system and I receive back this information, and I send a command to my production line, and do I get the feedback? So you can create from very small unit tests to larger functional tests, and actually generates code coverage outputs as well in different formats. For example, at CleverDisk, we use output to feed our Sonar Cube, which is our software quality software that we use. So we can analyze, for example, like you can see in this project, we have an agreement of reaching a 70% of unit test code coverage for this project. And there you can see the different classes and the different code coverage per class and so on. I believe this could be for a full other webinar, which is development processes.
With quality control and all those aspects. Yes.
Quality control, exactly. Please let us know if you're interested in such a webinar, no DevOps or best practices in development when using specifically WinCCOA. Oliver used then following another module, which is called Molder. Molder is used to create configurators, what we call. So these configurators are objects, tools that they are used afterwards to configure the different object types. It's actually very powerful because it allows, for example, to have multiple configurators for a single type class. So, for example, for a conveyor, Oliver, I think, will demonstrate this today. We could have different type of conveyors, perhaps deriving types. So we have slightly different types, and we can use the same configurators for these different types, so these different classes as well. It also allows to concatenate parameters. So in practice, you can match any namespace. For example, we have different PLCs from different vendors, like we said last week, different system integrators that created a little bit different namespaces. It's the same type of object, but I need to address the hardware differently. SmartNodes++ Molder module allows to pretty much match any namespace, even using arithmetic operations with the parameters. So we could say that there is an offset in one of the columns that needs to be added to another column, so you can actually match whatever you need. After using Matcher, Oliver used Matcher to create many instances of these conveyors, and applying at the same time the hardware connectivity, like Oliver was showing, alerts. I believe he also did some demonstration, creating some Boolean alerts, but it could be archiving and many more, so Matcher more, no, in practice. There was a question actually during the webinar related to this, which was if it was possible to change an individual attribute after the generation. Yes, of course, it is possible to change. Nothing prevents to change. It is probably not recommended. We wouldn't recommend if we enter into a mode where we are having some sort of, as we will show later with different modules, if we want to have a bit of control, version control to some extent, or even configuration control, we should not change manually. So we will recommend here to create two different molds in this case, and apply different mold to the different elements, even if it's just one different attribute.
You can do this customization to any level of detail you want for one attribute on one object, or hundreds of objects as you want. Yes.
There was another question related to this topic. Does this work with distributed servers? We understand distributed systems. Yes, it does work with distributed systems as well, even in distributed servers. And what about making modifications in running servers? Again, if this is a running production system, even we believe that there is many advantages. There are many advantages provided by Matcher because it allows to see the online configuration versus the expected configuration, and allows to decide before overwriting any existing configuration if this is the desired configuration.
And you can also automate your deployment sequences, so you can do them very quickly and also repeat them many times. So you can try in an offline environment, go to your production environment, and you're already confident that that deployment will work because you've tried it elsewhere first.
This is part of Builder, right?
Yes, we'll see that. We'll see that in a bit more detail.
Correct. Third question about this was, do I need to use Excel or CSV files in practice? Well, the short answer is no. SmartNodes++ provides natively an interface to use Matcher with Excel files, but it also provides an API, programmable API, So you can build your own way to use Matcher API and actually connect to your external database, for example, or to any other automated system that you have that can generate the configuration. So you can be creating the objects pretty much automatically. After this, Oliver showed Ladder. Ladder is SmartNodes++ module to create hierarchies, views of your system. It's a very effective and quick way to create what in WinCCO is called CNS views. And in practice, you create relationships between the different objects that you already created before with Matcher. Finally, Oliver showed and will be showing now Builder module, which we were referring to it a few seconds ago. Builder module, it provides a way to install like an installation tool in practice to install your different configurations, your different molds, and your different ladders and hierarchies and so on. And it actually provides a history. As you can see, there's a history here small in the screen. It provides a history of what was installed in this production or test system or development system, and in which order these different things were actually installed. So yeah, the history. There was a question that was, is it possible to use this generation tool as a version control system? Well, it is not really a version control system. It does, however, provide the history of the configuration install of the project. And normally what we do in our case is actually the files that we are applying here are under control version. I think Oliver is going to show this also at the beginning of the demo today. And yeah, I mean, in practice, this is a summary, a very quick summary of what we saw in part 1. And I mean, as you can see, we focus a lot in the OT part somehow. And we said the SmartNodes++ helps to bridge the OT and IT gap. So I believe today is the time to show how actually we can also model IT and enterprise classes and create objects and connect finally the IT and OT world very quickly using a SmartNodes++. Just before I hand it to Oliver so he can start the demo, just a quick reminder, we talk about the SmartNodes web part 1. It will really be great if we get even more feedback from your side. We will welcome any comments you want to drop into our LinkedIn Cleverthies webpage. What are you liking about our webinars? What you don't like? What would you like us to talk about next time? If you have any ideas of topics, any feedback is really very welcome. So let's move on to the demo. Oli, are we ready?
Yeah, ready. Okay.
Let's switch to your share screen.
So yeah, as Bobby was saying, this week we'll be looking more on the business logic side, the IT side of things, rather than the OT connecting your devices to the hardware, which we managed to get working with the conveyors last week. So yeah, I decided to start with a completely fresh project this week, because then we can show how you can use a version and control system to pull files into your project and then recreate it to a certain state. And the state we're aiming for is the state that we got to at the end of last week. So I'll show how we can do this. So this is a project which is a new project, but with SmartNodes++ already installed. So I'm just going to start my project here. That's coming up.
You have a license, right?
Okay, so that's fine. That's my Getty, and here we see SmartNodes IE. So because this is a fresh installation, there is none of the objects and classes that we had previously created. So the conveyor type that we created and the product type that we created last week to have these conveyor systems are not here. And all of the other modules are equally empty. There's just the default configuration. So how would we go about adding those files, that data, to this project? Well, I'll show you exactly how to do that. So, in fact, I've been using GitLab. I put all the files from last week into GitLab, and what we could do is we could either check out or download a snapshot of the repository at a certain moment. So I'm taking that down now. Let's go and have a look. That's going to appear in Windows Explorer now. Okay, so this is my zip file of the snapshot of the master branch in the repository. What I'm going to do is I'm just going to take those files. You see the structure. I've chosen to structure them in the same way as a WinCCUA project directory. So what I'm going to do is put them into my project directory directly. So my project is called SNPP Demo Part 2, which is this one here. So if I paste those in there, it's going to add them in. We can already see in the Getty that those files are being shown as new files. I have some duplicates, I'll skip those. Okay. So now if we look back in our Getty, we see there's many new files which have been added. SmartNodes++ is still not aware of those yet. So there's a few ways that we could import those. Basically, each of the modules has some way of importing work that's already been done previously. Or what we could do is we can go back to the Getty and we can just say install SmartNodes. And this is going to do a check of any additional files related to SmartNodes which have been added to the project. So it's going to be searching through the project and it's going to find, for example, this conveyor file which contains the class information for the conveyor. So it says it's finished the installation, so it's imported all the files it could find. Now, if I restart my IDE window, we will see pretty soon. Now we see we have more classes. So we have the conveyor class again. We still don't have the objects though. So there would be two ways to create the objects. Either we can go to our Mucher, where you see now we have the molds. So we have the conveyor mold, and I could drag my file in like we saw last week and click generate the objects. But there might be multiple of these files that I have to import, and there's also the ladder file as well that I want to import for the CNS view. So this is where Builder comes in handy. If I click on my factory recipe, in fact here I've got a slightly extended version of the recipe that we created last week. What I've got is I've got the conveyor mold and I've got the shop floor CNS mold ladder, excuse me. But I've also added a couple of extras. So there's ones related to the OPC UA client and subscription. So these are going to configure the internal data points of WinCCUA. So when you go to the system management to create OPC UA information here, OPC UA client, you see in my project this is currently empty, but we will need one of these because our conveyors, we are reading them out with OPC UA. So this mold that I have here is going to create the OPC client, and this will create an OPC subscription. And I've also got the simulator, which is the simulator that we needed to simulate the behavior of the items on the conveyor belt. So the good thing with Builder is that we can just click the run button. It will apply all of those steps. It's very quick, and that's all done now. And if we look in the bottom right, we see in the configuration history that Bobby was discussing earlier, that we see that 5 configurations have been applied. We know when it was done. We know that it was done as part of the sequence called the factory recipe, which is the one that I just imported. And we can see exactly the name of the mold or ladder that was imported with the data file. So we have that traceability of all the actions that have been taken in this project.
So what is our current state? I understand that you just took a project from scratch.
Yes. And
you went back to the state where we finished the webinar part 1. Is that correct?
Almost. If we look now, we can see if we go back to our conveyor, we have all the conveyor objects. We also, if we go to ladder, we see that we have the shop floor CNS hierarchy, so that's there. There's just a couple of things that we need to do still. For example, we had a panel where we could visualize all of this last week. So first of all, let's just add that into the project administrator. And we should start it always, and I'm going to run it as a user called Para because it needs rights to create things in the system. Okay, this is looking familiar to those of you who saw the webinar last week. we can start, these things are working, we can place products, we can place the tire on the conveyor belt. However, we don't have the simulation behavior yet. The reason for that is that I said we imported the simulation as part of the build process. So if we look at the simulator, we have a simulator object. What we need is we need a control script to run in the background and actually execute that behavior. And this introduces a new feature of, well, a feature of SmartNodes++ that we haven't seen so far, which is called the Runnable Objects. This simulator class we see has the method called run. So this is the entry point for Runnable Objects, a run method, and anything that's in that run method will be executed when we try and run a runnable object. To run these objects, I need a control script, which is called run. And I'm going to put that into my console as well. And I need to give the class name that I want to simulate. So in my case, the class is called simulator. I want this to run always. It will start up. And actually, as soon as it starts, the simulation should start working. So my tire's already moved. If I start up this one, it should start moving again. So now we've got back to the same state that we were in at the end of the last webinar, from a clean project to a working project in just a few minutes. Okay, so now let's try and extend this. So when we looked at the tires last week, the first type of product that we had, we said that a product was going to have a weight. So we had a product class which has a weight, and the tire, because it's a child class, it inherits from the product. It means it has a weight too, but it could have other properties if we wanted. However, what we're not doing is we're not choosing the weight, we're not setting the weight. So for sakes of this demo, what I'm going to do is every time we create a tire in the system, I'm going to set the weight of it. Now, it could be 12 kilos. We might want to make some randomness, so not all the tires weigh exactly the same. The rand function in WinCC returns between 0 and 32,000. So if I divide that by, let's say, 15,000, that is going to give us 12 plus a couple of kilos kind of thing. So 12 to 14 kilos our tires could weigh. While I'm here, I'm also going to create another kind of product that could go along the conveyor belts. Let's create a suitcase. And again, let's choose some weights here. So let's say this is going to be set weight. We could start with 12 kilos again. That's a relatively light one, but we want to add a bit more possibility of weight here. Let's add, if we divide by this, that's going to give us maybe plus 20 kilos. So we can get up to 30 kilos for a suitcase, which sounds reasonable. Okay. So let's just check if that's working. I'm going to get my panel back again for the simulation. Here we go. So I'm just going to stop one of those so I can look at the tires. So I put a tire here. If I put the mouse over, this one is weighing 12.93 kilos. Sounds reasonable. Let's start the conveyor so that one can go. And I'm going to stop the conveyor again, and let's put a suitcase on there. There's the suitcase with the suitcase icon. That one weighs 13. Okay, fine, good. But now what we have is we have a way of injecting different products, different types, and they have some weight. So there could be, we could start doing some business kind of logic here. The weight of these products varies, so maybe we want a kind of conveyor that sorts things based on the weight. If the weight is too high or outside of a certain range, we might want to discard the product. So I'm going to show how we can do that. So, like I said, it's going to be a type of conveyor. It's going to be a special conveyor. So we can derive from the conveyor class a new subclass. So I'm going to create a subclass of conveyor, and this is going to be called a sorter. So this is going to be a conveyor which can sort things based on certain properties of the product that's going past. Okay, the sorter by default is going to have all the attributes of the parent class, but we want to add a few other things. So I'm going to add, for example, this is the a float, which is going to be the target weight. So what is the expected weight of the product that we're aiming for? We will have a tolerance as well, so how much either side of that target weight is okay. We could have a Boolean that says, raises the flag saying this product is being discarded. And also have an accumulated count of the discarded, there's a typo there, the discarded count of products. So yeah, like last time, we can generate the getters and setters automatically, so the code is generated for us here. We don't have to write all of that. And that's the basic structure of our sorter. Now, to do the logic of sorting, I'm just going to skip ahead a bit here. I've got some pre-written code, so I'm just going to paste it in just to speed things up a bit. But I'll explain what this code is doing. So I'm adding a new method called sort, which takes current product ID, the ID of the product which we want to sort. It's going to get a pointer to that product as an object. It's going to get the weight of it and check it against the target weight and tolerance of the sorter. So if it's higher than the target weight plus tolerance, we should discard. If it's lower, outside of the range on the lower side, we should also discard. Else it means it's okay, so we clear the discard flag and say that everything's fine. In the discard product method, we're going to set the discard flag to true, remove the product ID because the product's been discarded, and we're going to raise that discarded counter by 1. So we have some logic in here, but
so you start to kind of count the good objects versus the bad objects. It's like some sort of quality to some extent.
We will get to that later, yes. At
Okay.
the moment, we're only counting the ones we discard.
I see.
Later on, we can look at the whole line and see how the performance of the whole line is working.
Mm-hmm.
So we have some logic here, but these are things which need to be called. The question is when should we call this sort routine? When should we say, now is the time to sort? So I'm going to propose that it's every time a new product is detected on the conveyor. So when a new product is detected, probably the setter that sets the product ID is going to be called. So we know that our conveyor parent class has a set product ID. It has getters and setters for all of its attributes, but we can override one of those methods. And by choosing override method, we can see all the methods on the parent classes, so the conveyor and the parent of the conveyor, which is the smart object. And I can choose the set product ID here. So I want to override in this sorter class a specific implementation of what that method should do. Okay. By default, it's called the one from the parent. So that means it will have exactly the same behavior as the parent. That's fine. But in addition, what I'm going to say is here is if that product ID is something different to blank, so there is a product there, then what I want to do is I want to sort, and I want to sort that product ID that we've just received and just been announced has arrived on this conveyor. So that is already being called by the simulator. So when the simulator calls that method, it should trigger our sort routine that we've just added here, which will check that sorter tolerance plus or minus a certain amount of weight. Okay. So just to refresh that, you see that we have this new view here.
So this was so what we have done now is that we have modeled one subtype of conveyor, which we call sorter, which is able to discriminate if the tolerance of the objects that they are going through is within accepted limits or not.
Exactly. So,
but we don't have any object. It's just the class, right?
It's just the class at the moment, and it's a specific conveyor that can sort according to weight. We could imagine sorting on other things like the type of the product, but at the moment we're doing the weight. You see in the UML on the right here, we can see that hierarchy of classes so that we see the smart object is the parent of the conveyor, which is the parent of the sorter. Okay, so let's try and create some of these. So I could create them manually and quicker, but let's use a mold because we've seen the molds already and they're quite powerful. Here, I'm going to create a new mold called the sorter mold. And as Bobby said, because this is a child class of the conveyor, I already have all the splices which were defined in the parent as well. So this is defined for the conveyor. If I click on the conveyor, we see it's there as well. So I can use that one. I can immediately use that because the running attribute exists for the sorter as well. You need to have it. So we need to read that as well. But we could imagine adding other things for the specific attributes of the sorter as well. And in fact, we'll see that in a second. But first, let's just create some of these sorters. I'm going to make sure that I've got the OPC UI addressing on the running bit, though. OK, let's come here and let's look at the sorter mode. And we're going to create a new data file. So this is the sorter definition file. It's currently empty, but let's add some sorters in there.
Yeah, let's remind here again that that we are opening these files with Excel, but this is a CSV file, right? So it can be opened by LibreOffice or it can be opened by other tools that support CSV files.
It's really my operating system, because I have Excel installed. It's proposing to open in Excel, but it's really a CSV file, and you can edit it with any CSV editor. You could even imagine to auto-generate them from other data sources as well. So this is going to be the OPC item, OPC device 1, for example. It has the same naming convention as the objects that we're creating, but they could be completely different, and we could do different manipulations, different order of those parameters. And the suffix, we just had some letter last week, so let's carry on like that. OK. We can refresh that, and now we should be able to generate.
Done.
If we look in the ladder, last week we were using this simple ladder configuration, but there's also one with the sorters. And you see that there's some differences from the existing hierarchy that we're doing. So what I'm going to do...
Can we remind what is these colors, Oliver?
Yeah, certainly. So the green means that it's already existing on the system and it's the same. The red means that it's existing on the system, but there's a difference. And for example, if we go to this detail column, you'll see that in this case, it's trying to match a different object to that node in the CNS hierarchy. So it used to be a standard conveyor, but now it's going to be a sorter. The gray ones are things that don't exist at all. So they're things that will have to be created. In fact, you see that if I click this button, it's going to delete the whole view. And then everything will be marked as not existing as well. Okay. So then you can see when we click generate, everything goes green, showing that everything now is consistent and everything exists. So let's go back to the panel again and see what's changed in the panel. That should start automatically.
Panel is reading directly from CNS views. So it's building the views depending on your hierarchical views or plant model views that are calling WinCCI.
So now the lines look slightly different. This top one, for example, is much longer because I added some extra nodes in that definition, and the sorters. You see the sorters have this special side lane where the discarded products are going to go. So these work just as before. You still have the 3D visualization. So all of that is the same as before. And what we can do is see how these work. So I'm just going to pause the production line for the moment. Let's put a tire on there. So this tire weighs 12 kilos, 12.69 kilos.
Yeah, I have a spontaneous question. There's no tolerance, right?
Exactly.
Okay.
That's what I wanted to show next, is that by default, all of these sorters have uninitialized tolerance and target weight. They're all 0. So let's just run it now, and we should see that that gets discarded straight away. The discarded count has gone up by 1. In fact, nothing will get along there.
So we just broke our factory.
Yes. Yes. So nothing will get through this production line at the moment. Now, how can we set these tolerances? Well, it's just an attribute on an object. So we could do it with quicker. We could go and set it down here, but it's much more convenient to do it on a more massive scale using Mutter and Molder. So let's go back to our mold here and extend it. Let's set up use splice on the target weight. And let's set one up on the tolerance as well. Okay, so the target weight we want to be able to have as an engineerable property, so we need a parameter for that. So this is going to be the weight target. You can choose any name here, it doesn't have to match the names of the attributes. If you want to provide a different terminology to your engineers who fill in these files, that's completely fine. Just get rid of the 0 there. Okay, for the tolerance, we do the same. Let's create an attribute there called weight tolerance. Okay. Okay, now we just need to add those 2 splices into our new mold, into our extended mold, the sorter mold. And now we come back to Matcha. And we've got our existing data file, but if we try and use it, it's going to say there's some information missing. Because you've added new parameters to the mold, you have to define the values for those parameters. So we ask, yes, please add those columns to the file. And now we can edit the file and give those values. So the 2 new columns are these ones at the end, D and E, which is the weight tolerance and the weight target. So the weight target, I'm going to say is 12 kilos. And the tolerance, I'm just going to set up them all different. 1, 2, 3, 4, 5 kilos. Okay. One interesting thing here is if you want details, because the sorters don't exist, they're marked in green. But you can dig down and view the bigger details. Yeah, okay, this we'll have to do later. Okay. I'll come back to that one. If we generate the objects, yes, okay, let me just restart the UI. The reason is that because we're trying to set here to the sorter mold. Let's start looking in there at the details. And we can see, okay, there's some differences in the values. For example, the value should be 1, but the current value is 0. So we can see desired value is different to current value. And we can do it for the target weight as well. The desired value is 12 compared to 0.
So this is what I was saying before, probably, no? There's a production system, you're bringing a new configuration.
Yes.
So you can actually review it before really applying it. Okay. You can validate.
So you can check down to the smallest detail what the differences are and what's going to be applied to your system.
The same will be for an address of a hardware.
Exactly. If it was an address, you see, for example, here, they're all marked as the same, but you see all the information.
All right.
And if there's any differences, it will be marked here as well. Okay. Okay. So let's regenerate that, re-import that configuration. And now we should see that our sorters will get some new configuration. I need to restart that panel as well.
Because they do a get on start.
Exactly.
Yeah.
Now it has 12 plus or minus 2 kilos, so this is sorter 2. This is 12 plus or minus 1 kilo, so this is sorter 1. So let's try and put a tire down there now. This tire weighs 14 kilos. Oh. That's bad luck. That's going to go straight out of the first one.
Right.
Okay, let's put in another one. Let's see if we're more lucky this time. This one weighs 12.86 kilos, so this one should get all the way down to the end. There we go. We can put in a suitcase. They're pretty heavy most of the time, so
that's going out.
That's 21 kilos. That's going to go straight out. So in that way, you can have this business logic, which is going to be based on your data and
it's
run
on weight.
in your SmartNodes classes. You can do that kind of business logic. Okay. So yes, another final point there is that you could imagine that you might want to reconfigure these weights during operations, maybe. So applying a mold with a data file can be seen also as a reconfiguration step, changing a recipe of your production lines or something to deploy some new configuration data. and then you can switch quickly between those different modes during your operation phases.
They might be connected to different products. No?
Yes, exactly. If you know you're doing one kind of product, you may set your tolerances higher. If you do a different production a different day, you may need tighter tolerances.
Right.
Yeah. Okay. So then the other point that Bobby was getting onto was that we might want to somehow evaluate the performance now of this. So we're discarding these products, but we should keep track of how much we're making, how much we're discarding. So far, these lines have just been derived from the structure of the CNS view. They haven't really had an object in themselves which keeps track of the properties of the line. So what I'm going to do now is propose to build one of those. So let's try and model some properties of our line itself. So I'm going to create a line. This one I'm going to put in the assets folder where we're putting all the other classes for the demo. And here we need some attributes here. So we're going to have some sort of performance, let's say. And then we will have an integer which is produced units. So this would be the good units that get to the end of the line. This would be the overall performance, so some ratio of what was discarded and what was kept. Okay. We need the getters and setters, so SmartNodes can help us with that.
That's the SmartNodes plus feature, right?
Yes. Yeah. We embed it into the script editor, but it's a feature of SmartNodes++. Okay. So that's in principle all we need so far. Let's try and create some of those. So let's go to create a mold. We're going to create a mold for our lines. At the moment, there's probably nothing that we want to really define in them at the moment. Let's keep it just as a simple mold like that. Let's call this line definition. There's a small typo there, but it doesn't matter too much. And let's call this line 1. We have 2 in our system, 3 in our system now, so I'll create 3, but we can create as many as we wanted. But now we have them. Now let's go back to ladder. And there's one more ladder, which I already had here, which is practically the same as the one that we had before, except we're associating the lines in the CNS hierarchy to those line objects. So we see they're marked as red because the associated object is different.
Right.
If we generate that now when we come back here, this panel is able to at least connect to those attributes, but we're not counting anything yet. We don't have any business engine, let's say, on the top here. That's what we're going to need to do next. So the performance calculator is a class which I've already got created. It just needs to be created with a specific view name to tell it which view to look at. It's not really coded to look at particular conveyors, particular products. It just observes the CNS and finds whatever it can in there and checks what
so it's sort of generic.
Along. It's quite generic.
It will work for any line of conveyors, of those conveyors you will create.
It's relying on certain attributes. So you need to have a product ID in your object, and you need to have a CNS hierarchy that has a clear end and a sorter that can discard product, or an object that can discard product. Okay, so we need to create one of these performance calculators. I already have something already created there. So this is a calculator looking at the shop floor. So the shop floor is the name of our hierarchy in the CNS. Just to remind you, it's this shop floor. So now it's working, it's installed, but we need to run it as well because it's one of these runnable classes. So let's add this performance calculator. Set that to run always. And okay, we already see some numbers here. So let's try on this simple one. Everything's going to get through. The production count should always go up, and the percentage will always be 100%. Let's try on this top one. That's going to be more tricky. These suitcases, most of them are not going to get through. I put some tires in the hope that they will get through. When something gets till the end, we'll see that the production count goes up. All of these discarded ones at the moment, the production count is not increasing.
That one is going through.
There's one going through there, so we should see this going up to 1, and we'll get quite a poor performance because so much is being discarded.
You're very intolerant.
But that's the way we set the tolerances, and we'd have to manage our business ourselves based on the information that that's giving us. So the final point that I want to look at today is how we could link this to some sort of enterprise business application that we might have.
Yes, that's what we came for, Oli.
And particularly what I'd like you to show you is that we have an enterprise system simulated here, which is Microsoft SharePoint, and it has a list of orders that we want to be executed. We want these products to be passed down our production lines. So you can see that we have an existing list here.
So this is a SharePoint list.
This is SharePoint. This is pure Microsoft SharePoint. And what I'm going to show you now is how we can link our system to this SharePoint list to automate our production flows.
So we're going to be sending tires from SharePoint in the cloud.
In the end, we will be able to go to here in the cloud, create our new order, and it will be executed on our production lines. Okay, so we need an interface to SharePoint, and in fact, I've already got one, let's say. So I've got these two classes, the SharePoint authentication and the SharePoint list. So I also have some molds predefined as well for those. So I have the SharePoint authentication. This is going to take care of all the information about how we authenticate. And importantly, we say the domain. So the domain is basically which part of the SharePoint domain are we wanting to address? So cleverdis.sharepoint.com. Then we look at the list. Go back to the list now. The list, which is going to be addressing this, it's going via a web service. We need to give the name of the site and the title of the list.
Are we going to look at those classes that appear magically, the SharePoint?
I can show the UML for them in a second. Yes.
Ah, great.
Yeah. So, and we have to then specify which authenticator object we want to use, which is the one we just created. So we can generate that as well. So now in theory, we have our production lines on one side and we have our data interface, but we're going to have to plug these together. Now, just to say what Bobby was asking, to look at these classes, we can get a quick overview here. We see all the methods on the right, the attributes on the left, and we can also see the UML diagram here. This one is quite simple. If we look at the SharePoint list, though, we'll see that the SharePoint list shows a relationship between multiple classes because it uses an authentication object as well. You see the SharePoint list is here. It's going to use the authentication, and both of those are derived from the smart object.
Right, so this is actually in practice connected to a real enterprise SharePoint.
Yes.
Okay.
Yeah, this is going to connect to the
and
real.
Authenticating, as I can see,
it's authenticating.
Authentication tokens and so on.
Exactly, it takes care of all of that for us. Yeah.
Okay.
Yeah.
Who created this? Was it fast or?
Yeah, we created this. It was just for the demo, so it was something quite quick to make.
Okay.
Yeah. Okay, the next thing that we need to bring this all together is we need some sort of order execution system. So actually, I'm not quite ready for that yet. We need also to create the order type. So we want to model the orders in our system. So I'm going to create a class called order.
So now is when we're getting into modeling enterprise objects, no?
Exactly.
So far,
we're taking
modeling conveyors, sorters,
definitely.
Even some production. But now we are actually modeling an order, which is something coming from
what we're going to do.
Or
what we're going to do is really create an object that represents this data, these columns here in the SharePoint list. Okay, let's look at the order now. So we're going to need some attributes here. So let's come here. If you want a private, we're going to have a string, which is an ID. We're going to have a private string, which is a name of the order as well. We want the product name, private string product. What kind of product do we want to create? We also want the line. Which line should it be executed on? We want an integer, which is the number of units to produce. And then we want a final state, which we're going to use to feed back to the list, which is the complete status of that when the order has been executed.
Feedback, you mean that you're talking back to the ERP, so you're not only receiving the order, but you're also
we will write back to the system to say, yes, we acknowledge that that order has been taken and processed. Okay, let's just do the guests and setters there. So that's our order model. That's the data model of our order now in WinCCOA with SmartNodes++. And then now I can go and get another class, the final class, which I've kind of pre-built just to keep the demo going smoothly. This top one, this unregistered order executor, I'm going to register that now. It's going to bring it into the system. This is how you can do when you exchange your classes with colleagues as well. You can also register them individually in that way. So let's click on here, the order executor.
So to give an idea of how long would it take to create a class like this, Oliver, in SmartNodes++, this order executor, which I understand is connecting, is reading the orders. I see the URL
exactly
now.
Yeah. So it's using the authentication system. It's using the list interface to SharePoint. We're using a web service, and it's then doing its own business logic. Okay. I'm going to show you the code. I mean, there's not much in there. It took me, let's say, less than an hour to create and test and get it working. So here we have the run method, which is where it's going to the entry point when we try and run this from the console. We need to somehow get the data back from SharePoint, the SharePoint interface, and unpack it into orders. So we get it back as a DIN mapping, and we unpack it and create new orders on demand. Then, basically we need to get that list and process the orders. So that's all the code there is. So let's come back to Matcha. There should be an order executor mode already existing. You see, this is just saying which interface do we want to use, which is the web service. So let's generate that. And now we should be ready to add that to the console. This is going to be an order executor. We set that to run always. And that should now be running. So let's test it. I'm going to come back to my SharePoint.
So that should be now connected to SharePoint, yes?
Yes, it should be connected, yes.
Okay.
So what I'm going to do is, first of all, I'm just going to reuse one of these. So for example, line 1 here. Let's just edit that one. I'm going to mark it as not complete, so that the system, when it's detecting it, it's going to say, there's an order that needs to be executed. And immediately we have 2 suitcases coming along. They're going to be discarded pretty soon. So would you like me to make a new order, Bobby? Is there something else you'd like me to do? So, of course, order 5. What kind of product would you like?
Let's try tires.
Tires, okay. Which line?
The first one, we have a shortcut, right?
Yeah.
Let's put some.
How many do you want to put?
12.
12, okay.
We can speak while they go through.
Okay, so we have the new order entered into SharePoint, and pretty soon afterwards, we see those tires now being produced and pushed along the conveyor. Okay, so there's 4 come down here. There's a few that have been discarded. Actually, what we could do is we could reset the statistics here to see clearly what was happening. All of these can be reset, but because we're starting from an existing point, those performance figures are not quite up to date. But overall, it's the performance of the full production that we've seen in the demo today.
The completion for order 1 in the SharePoint?
It's not complete.
Order 1, yes. Order
not
5,
yet.
no, because it didn't fit.
So it's still generating them. It's probably finished now.
That looks like the last one, right?
That looks like the last one.
I should say 7.
12 is okay. They go fairly quickly. So yes, this should be updated. If I refresh the list now, we'll see that it's been marked. Yes, it's been complete.
So you close the loop to the enterprise system.
So we have a full link.
Web services, authentication, connected to external system, modeling order object, enterprise objects.
Yes.
Having an order execution processor.
And then feedback to say.
And a feedback to the ERP.
Yeah.
Wow. Okay.
Okay. So that's all I wanted to show. I hope you enjoyed it. I hope it was interesting for you. Now I would pass back to Bobby. We'll see if there's any questions that we have to answer. And there's also just a few comments and things that we'd like to mention before we finish today.
Right. Okay. So that was actually very interesting, Oliver. Let me just switch the view modes. It should be okay. So we actually don't have much time. We're getting some questions, but we're going to be coming back to you. Please don't hesitate also to write an email to us. And if you are joining the webinar today and we didn't get the time to answer pretty much any question in practice, so please go ahead. And actually, if you want to talk also you're interested in trying SmartNodes, just please either contact directly to salescleverthis.com or directly to Marco Anderka if you're familiar perhaps with Marco. Just if you need to get the demo version or you're interested in actually jumping into using SmartNodes, as we said, it's productivity tool, cut your engineering time in half, become twice faster. That's the value you can bring to your customers. We have very interesting packages. You can start using SmartNodes++ by yourself immediately. You can use it together with the training, also in very interesting packages our sales guys put together. So please, get back to us. And just one more time, if I may, it will be great if you drop us a line in our LinkedIn webpage and you let us know what do you think about this webinar, the live demo that Oliver made. Would you like us to keep doing more of these ones? And do you have some idea for the next one? SmartNodes++ works for, like we saw, conveyor line, but we've used it in petrochemical projects. We've used it in manufacturing and energy projects. We've used it and transportation projects. Also, Siemens is using it in intelligent traffic systems as well. So please let us know, and we come back to you. Thank you very much. Stay safe.
Yeah, thanks a lot.